Hi everyone, I am Anitha working as an assistant professor of chemistry at Laxman Institute of Technology and Management. In the previous video, we have discussed about cement, its types of cement, and the composition of cement, and the how the setting and hardening of cement takes place. We have discussed from engineering materials chapter. Now, from this chapter, today we will discuss about one more topic, that is lubricants, its introduction and the classification. Now, today we'll discuss about the topic lubricants. In this session, we will discuss about what exactly the lubricants are. Now, in this introduction of lubricants, what is meant by a lubricant? What is meant by a lubricant? Suppose if we take a machine, in that machine, if only one part of the machine is moving, then there will be no friction. And if two parts of a machine are moving in opposite direction, that means, for example, if one part of a machine is moving like this and another part of a machine is moving like this, that means one is moving in the forward direction and the other one is moving in the backward direction. So in this opposite direction, if these two parts are moving in the opposite direction, at any point of time, they may come into contact with each other. Okay, so then they may come into contact with each other. At that point of time, it causes a friction. Right? So to reduce that friction, we need to add something into it. What is that something? That something is nothing but the lubricant. Clear? So now in this class, we'll see about what is meant by lubricant, introduction and the classification. There are few different types of lubricants are there. Different types of lubricants we use for different types of machinery. All those points we will discuss today. Now see here, what is meant by lubricants? The substances. What is meant by a lubricant? The substances. Any substance which are used to decrease the force of friction. Yes, just now I said, when two parts of a machine are moving in the opposite direction, then what happens? At any point of time, they may come into contact with each other. So it causes a friction. To reduce that friction, we need to add any substance. We need to add something or any substance. That substance is called as a lubricant. So what is the main function of this lubricant here now is it reduces the friction. Okay, so that's why here in the definition you can see, to reduce the force of friction between the moving parts of machine in contact are known as lubricants. And this process of reducing friction between the moving parts of a machine is known as lubrication. Clear? So this is the introduction of lubricants. Now we'll see what classification of lubricants. So what is in the classification of lubricants, based on their physical state of the lubricant, it is classified. These are classified into liquid lubricants, semi-solid lubricants and solid lubricants. Okay, so here it is the liquid lubricant, semi-solid lubricant and solid lubricants. Okay, so these are the three types of lubricants. These are classified based on their physical state. Okay, so here all these types of these three types of lubricants are classified means, in all the types of machines we can't use a single lubricant. Okay, a single oil does not possess all the properties of the lubricants. Okay, so that's why we are using the different types of machines and different temperatures we maintain in the machines. That's why based on the type of machine and what the temperature you are using in that machine, based on that we need to use the lubricant. That's why these lubricants are classified into liquid lubricants, semi-solid lubricants and the solid lubricants. First one by one we will discuss now. What is meant by a liquid lubricant? So here, what is meant by a liquid lubricant? These are also called as lubricating oils. These lubricating oils, they provide a continuous fluid film over the moving surfaces. In the moving surfaces of the machine, when you apply an liquid lubricant, it forms a continuous film. Okay, so it forms a continuous film, and because of the friction, there will be heat also generated. That's why when you apply a lubricant, it acts as a cooling agent, sealing agent, and it also prevents corrosion. These lubricating oils are further classified into three types, that is animal oil, vegetable oil, mineral and petroleum oils, and the blended oils. Now we'll see what are these different types of liquid lubricants. So what is meant by liquid lubricant, students? Liquid lubricant means here they form a continuous fluid film, they act as a cooling and sealing agent, and it prevents corrosion. These are of three types. Now we will see all these three types. The first one is animal and vegetable oil. What is meant by animal and vegetable oil means here these types of oils are mainly extracted from the animals and the vegetable oils. Okay, so they are extracted from the animals and the vegetable, in the sense it is nothing but the plants. So from the plants these are extracted. So these oils, both these animal and vegetable oils, they possess good oiliness. Okay, so they possess good oiliness and they can stick on metal surfaces effectively even under elevated temperatures and the heavy loads. So even the heavy load is there also, these type of animal and vegetable oils, they can stick finely on the metal surface. And these animal and vegetable oils, they suffered from few disadvantages. Okay, they suffered from few disadvantages. They are costly. For example, if you take the raw material, like for example, we are extracting the oil from the plants, and we will take the large quantity of raw material, but finally we will get very small amount of the oil. Okay, so that's why, so they are costly. They are costly. And these animal and vegetable oils, they undergo oxidation. They undergo oxidation to give gummy product. They undergo oxidation to give gummy product. That means when they are exposed to oxygen or the ozone present in the atmosphere, when they are, or the moisture also, sometimes moisture or water present in the atmosphere, then they undergo oxidation. They undergo easy oxidation. Why they undergo easy oxidation means, these animal and vegetable oils, they contain the fatty acids. Clear? In their composition, they contain the fatty acids. So because of the presence of fatty acids are there. These fatty acids, they undergo easily oxidation when they exposed to oxygen or ozone present in the atmosphere. They hydrolyze easily on contact with moist air. Hence, they are rarely used these days for lubrication. Okay, so what are these different types of examples of the animal and vegetable oils? Whale oil, fish oil, olive oil, palm oil, castor oil, and almond oil. Now the next one is mineral or petroleum oils. These mineral oils are refined petroleum based hydrocarbons. These are made from the crude oil, which are obtained from the fractional distillation. Once you go through the topic of fractional distillation of petroleum, in that, if you see that topic in the fractional distillation, we can see there are different fractions of oils, different fractions of, based on their boiling point in the refining of petroleum, different fractions of oils gets separated. Okay, so in that different fractions of oils, we will take the petroleum oils, and these petroleum oils also act as a lubricants because they contain the low molecular weight. They contain the low molecular weight of carbons. 12 to 15 carbons are present, and as they are cheap and available in abundance, they are widely used. Now, here these are obtained from the refining of petroleum. We are taking the petroleum-based hydrocarbons. They contain, but the oiliness of the mineral oil is less. If the oiliness is not there, we don't want to use that oil. Clear? If the lubricant means, it should have the oiliness, right? So if the oiliness is less, we don't want to use such kind of lubricants. So that's why what we are doing is to improve the oiliness. To improve the oiliness of this mineral oil or the petroleum oil, we need to add high molecular weight compounds. This mineral oil is the low molecular weight compounds which contains 12 to 15 carbon atoms. Okay, so here high molecular weight compounds like fatty acids like oleic acid, stearic acid, palmitic acid, all these are added as an additive to increase the oiliness of mineral oil. So why we are adding these additives means to increase the oiliness. If oiliness is less, we don't want to use such kind of a lubricant. So to increase the oiliness, we are adding the additives like of high molecular weight compounds. We are adding so because of this adding of additives, it leads to the generation of one more type of lubricant which is named as blended oils. Okay, now in this liquid lubricants, the third type of oil is nothing but the blended oil. So what is meant by blended oil? Blending. What is the meaning of blending? Blending is nothing but mixing, right? So what we are mixing? We are adding additives to the hot lubricating oil. So or the mineral oil. So here no single oil does not possess all the required properties of the lubricant. Okay, so here that's why, and hence we need to add the proper additives is essential, so to make them perform well. Such lubricating oils are called as blended oils. So what is meant by blended oil? We are adding the addition of higher molecular weight compounds like fatty acids like oleic acid, palmitic acid, stearic acid, all these we are adding to increase the oiliness of the mineral oil. So this is about the liquid lubricants. So liquid lubricant, it can form when you apply a liquid lubricant between the two parts of a machine, it can form a continuous film. These liquid lubricants are of three types. What are they? Animal and vegetable oil, mineral oil, and the blended oil. And the next come to the second type of lubricant, that is semi-solid lubricant. What is meant by semi-solid lubricant? Here it is semi-solid. That means what? It contains half part. It contains half part solid, and that means 50% of solid and the 50% of the oil will be there. So in the place of solid, what is solid? In the place of solid, what we are adding? In the place of oil means what it is. When you add these two, then we will get the semi-solid. Okay, so when we add these two, then we will get the semi-solid, which is nothing but the grease. So a semi-solid lubricant obtained by combining lubricating oil with thickening agent. Why we are adding here this solid means to increase the thickness. To the oil we are adding the solid substance to increase the thickness, that is called, then the semi-solid lubricant is obtained. So to act as to increase the thickness or to act as a thickening agent, what we add thickening agent means in the place of this solid we add the soap. In the place of this oil, we will take either animal or vegetable oil or the mineral oil mainly. So here to the oil, soap is added to the oil. Then we will get a semi-solid substance which is nothing but the grease. Okay, so these greases are prepared from the saponification of fat. We are adding soap to the oil. This is called as a saponification. Okay, so it is called as a saponification, and the chemical reaction taking place in that one is the esterification reaction. So in this esterification reaction takes place in the presence of alkali. So in the presence of alkali, esterification takes place. So what we are adding here in the place of solid means here it is the soap. This process is called as the saponification. So grease can be prepared from the saponification of fat with alkali, followed by adding hot lubricating oil. So here in the place of soap also it is not a single soap. Okay, there are different types of soaps are there. Based on the different types of soaps, different types of grease is obtained. Two different types of machines we use all these different kinds of grease. So here in the place of soap we may use this lithium soap, sodium soap, calcium, barium, aluminium, like this. These different types of soaps will be added to the oil. So here grease can support much heavier load. Grease can support much heavier load at lower speed. Here we need to observe this. What is this lower speed? When the machine is moving with the lower speed, this semi-solid substance, that is grease, it can stay at one place for a longer duration. Okay, so heavier load, but the lower speed should be there, and the lower temperature also should be there. If the machine is moving with high speed and high temperature, these grease cannot be preferred, we cannot use. Okay, so here if the machine is moving with high speed, then what happens? If it is moving with the high speed, then this grease it cannot stick at one place. Okay, it will be missed. So now temperature, here the temperature also it should be less. Temperature also it should be less than 80 degrees centigrade. More than 80 degrees centigrade is there in the machine, we cannot use this semi-solid lubricant. Why? Because if the temperature is more, sometimes it converts into liquid. It converts into liquid, and such kind of liquid lubricant we cannot use in these types of machines. Now here, this is about the semi-solid lubricants. In the semi-solid lubricant, it is also called as grease. How this grease is obtained, we have to add solid to the liquid. In the place of solid, what we are adding? We are adding the soap. Now the next here in this, for example, in this semi-solid lubricants, why we are preferring the semi-solid lubricants? Okay, why we are not using this liquid lubricants in these machines? So why means a few kinds of machines will be there. Those are the machinery which are used in textile industry, food industry, and paper industry. In these kinds of machines, we cannot prefer the liquid lubricants. Why? Because what's the reason is, if we use the liquid lubricant, what happens? Sometimes the liquid spills on the paper, or liquid spills in the food, or on the cloth. Okay, what the lubricant you are using, your lubricant should not damage the product. Okay, your lubricant should not damage the product. So that's why in these kinds of machinery, the semi solid lubricant is preferable. That's why we are going to the semi solid lubricant instead of liquid lubricants in these kinds of machinery. Now come to the third type of lubricants, that is the solid lubricants. See students, here the lubricants are classified into three types: liquid lubricants, and then semi-solid, and then solid lubricants. Now we'll see what is meant by a solid lubricant. So here in few types of machines, we cannot use both liquid and semi-solid lubricants. We need to prefer only the solid lubricants. So why? Because combustible lubricants must be avoided. So what is meant by this one? Combustible lubricants must be avoided, which means what? Combustible, how the combustion reaction takes place in this one. So when we use, why we are not preferring liquid lubricants in the machinery which are running with up to 1000 degrees centigrade temperature. So here the combustible substances or the lubricants must be avoided means, if we use, for example, if you use liquid lubricant in these machinery which 1000 degrees centigrade temperature is maintaining, that liquid lubricant it may evaporate. Okay, that liquid lubricant it may evaporate, or even if it stays at that place also, sometimes it will react with the gas and the combustion reaction takes place. When combustion reaction takes place, because of that fire, the entire parts of the machine will be destroyed, right? Will be damaged. So that's why combustible lubricants must be avoided. Now, have you understood? Combustible lubricants must be avoided. So here liquid lubricants, it may evaporate or it may react with the gas and combustion reaction takes place. And sometimes if we use the semi-solid lubricant in these machineries which are maintaining 1000 degrees centigrade, if we use the semi-solid lubricant, then what happens? That semi-solid lubricant, it converts to liquid sometimes. Okay, so that also not advisable. So here that's why we need to prefer only the solid lubricants. These solid lubricants used either as a powder or it is used in the colloidal dispersion in water. That means this solid powder lubricant, it is added with water. It is added with water, which is called as aqueduct, or it is added with oil, which is called as oil duct, to make them stick firmly to the metal surface while in use. Okay, so here this solid lubricants, they can be used either in the form of a powder, or that powder is mixed with either with water or with oil. Clear? So in such a way we can use this type of solid lubricants. And what are these solid lubricants? The most widely used solid lubricants are graphite and molybdenum disulfide. So the most commonly used solid lubricants are graphite and molybdenum disulfide. So why only these graphite and molybdenum disulfide are used means mainly because of their structure. Okay, so because of their structure, these are used, most widely used as a solid lubricants. Now we'll see what is its structure, in what way or how we can use these solid lubricants in the machinery. Now we'll see. First we'll see graphite. In this graphite, it is most widely used. It is most widely used of all the solid lubricants. It is most widely used of all the solid lubricants. It is soapy to touch and it is non-inflammable. It is stable up to 375 degrees centigrade. And now if you observe the structure of graphite, it is a flat plate-like structure, and the layers of graphite sheets are arranged one above the other. Layers of graphite sheets are arranged one above the other, and these two layers are held together by weak van der Waals forces. Okay, now we'll see the structure of graphite. If you observe the structure of graphite, here just now we discussed that how the structure will be layers. Okay, layers of structure will be there, and all these layers are interconnected, held together by weak van der Waals forces. Okay, so if you see the structure of graphite, if you observe the structure of graphite, here all these total structure contains only one element, that is the carbon. Okay, so here the two carbon atoms are interlinked or bonded together by a strong covalent bond. So it is a hexagonal structure is there, and in this hexagonal structure two carbon atoms are there. All the carbon atoms, that means between two carbon atoms covalent bond, and between these two carbon atoms a covalent bond, like this between the atoms in each layer. Got the point? Between the atoms in each layer, these are held together by the covalent bond, by the strong covalent bond. And next like this one more layer, here also the covalent bond, and next the third layer, here also the covalent bond. Now if you see here the two layers, okay, so here the two layers are these two layers are bonded together by weak van der Waals forces. Okay, so by weak van der Waals forces. So these parallel layers which can easily slide one over the other because of this layered structure. So here here we are observing the graphite structure. What is this? How the structure here? It is the layered structure, layer by layer structure is there here, right? So when the machine is moving, when the machine is moving, what happens, these layer, first one layer stick to the surface, then again it is moving, another layer stick to the surface, like this, one by layer it will stick to the metal surface between the moving parts of a machine. So here, that's why between these two, between the two layers of this graphite, weak van der Waals forces are there. Between the carbon atoms, covalent bonds are there. Between the two layers, van der Waals forces of attraction are there. Okay, so because of this layered structure, it can easily slide. It can easily slide one over another, make graphite an effective lubricant. Okay, so here, make graphite an effective lubricant. This is the structure of graphite, and now we'll see the one more solid lubricant, that is MOS2, that is molybdenum disulfide. So this, if you observe this structure of molybdenum disulfide, what is its structure means, here it is a sandwich structure, and you all know the meaning of a sandwich. What is meant by a sandwich, how it will be, there are different atoms. Here if you see here, it is MOS2, the sulfur atom. First, all the sulfur atoms are linked together. This is one layer. And next one here, molybdenum. All the molybdenum atoms are linked together. It is one more layer. And then again sulfur. And then again molybdenum, again sulfur. Like this, sulfur, molybdenum, then sulfur, molybdenum, like this, layer by layer. Here also, layer by layer structures are there. So, what is the structure of molybdenum and graphite? Both are layer by layer, but in the graphite, all the atoms are carbon atoms. All the atoms are carbon atoms, but whereas in the case of MOS2, this also layer by layer structure, but the atoms are different. Okay, that's why we have given the structure name. It is a sandwich-like structure. Sandwich-like structure with a layer of molybdenum atoms in between two layers of sulfur. All these are hexagonal. And here also, just like graphite, in the graphite, between the carbon atoms, strong covalent bonds are there, and between the two layers, there are weak van der Waals forces are there. And here also, between the sulfur atom, between the sulfur atoms, strong covalent bonds are there. Between the molybdenum, also strong covalent bonds are there. But between the two layers, there are weak van der Waals forces are there. Here also, layer structure. So that's why this one can be effectively used. It is stable up to temperature of 400 degrees centigrade. Now come to the conclusion of the topic. That is, here in this session, we have discussed about introduction of the lubricant. What is meant by a lubricant? What exactly the lubricants are? We have discussed. So when the two parts of a machine are moving in the opposite direction, like this, in this opposite direction, at any point of time, they may come into contact with each other. Which causes a friction. So to reduce that friction, we are adding a substance that is called as a lubricant. And there are different kinds of machines we are using in our daily life or in the industries. So in the different kinds of machines, we are maintaining the different types of temperatures. So based on the different types of temperatures and different machines, there are different kinds of lubricants are there. So what are those different kinds of lubricants, how they are prepared, all this we have discussed. So what are these different kinds of lubricants? We have discussed about liquid lubricants. Here in this liquid lubricants, what are the liquid lubricants? We have discussed animal oil, vegetable oil, mineral oil and blended oil we have discussed. And next, the semi-solid lubricant or the grease, how the grease is obtained, how the grease can be prepared by the saponification of fat. That is, we have to add the different types of soaps are there. Those soap is added to the oil, which is called as a saponification. This saponification takes place by a chemical reaction called as esterification. In presence of an alkali, it takes place. In such a way, these greases are used. And next, the solid lubricants. So in this solid solid lubricants, if the machine is, we are maintaining the temperature in the machine, if it is up to 1000 degrees centigrade, then in such machines we cannot use liquid lubricant and we cannot use the semi-solid lubricant. So that's why here we solid lubricants are prepared. What are the most widely used solid lubricants we have discussed, and that is graphite and molybdenum disulfide. Okay, clear? So this is the lubricants topic from engineering materials. I hope this video helpful to you. Thank you.